a figure. Now we go on to the topic, concept of seafloor spreading. Now this is where things get really interesting. So you remember Alfred Wegener's continental drift theory? In case you haven't seen the video, I recommend you do so. The video link is in the description, or you can also click on the info card on top. Wegener's theory focused more on the continental evidence, like the fossils of animals found in various continental landmasses, then how the South American East Coast kind of looked like a missing puzzle when joined with the African West Coast. So things like that were Alfred Wegener's arguments. Now what happens is the post-drift studies gave some valid arguments and information against Wegener's continental drift theory, especially mapping of the ocean floor and testing of oceanic rocks were very crucial steps that were taken by the scientists. They revealed some real facts that gave the post-drift study good amount of weight when compared to Wegener's continental drift theory. I know things are getting a little confusing, so what I'm going to do is create a nice differentiation between both the theories side by side so that it makes clear sense as to what is what, and it will also serve as a quick revision. So on your left hand side is the continental drift theory given by Alfred Wegener, and on your right hand side is the post-drift studies which were done by various scientists, just to prove the point that there are reasons much more beyond what Wegener suggests. The continental drift theory talks about the matching of continents. Wegener said if you look at South America and Africa, they look like a jigsaw puzzle fit when brought closer. Which is true that once upon a time both land masses were together, but the reason behind that is much more deeper than just merely looking at the world map and saying they were once together. The second point in continental drift theory talks about the fact that rocks from different continents were of the same age. And this point made Wegener believe that the land masses were once together and they slowly drifted away. Again, the reason behind the drifting is much deeper than just looking at rocks and saying they all are same. The third point in continental drift theory talks about tillite formation. The Gondwana land consists of 6 land masses. They are India, Africa, Madagascar, Australia, Antarctica and Falkland Islands. Under the base of these 6 land masses, tillite sediments were found. So that made Wegener think that okay, these 6 land masses were once together and now they are apart. So this is a pretty good observation. However, the reason is much bigger and in depth rather than observing tillites. The fourth point in continental drift theory talks about placer deposits. They are deposits of rich minerals like gold, diamonds, etc. So if you look at the coast of Ghana and then coast of Brazil, you'll see that these placer deposits looks like vein that were once joined together. This point again made Wegener believe that Africa and South America was once a single landmass. And the last point in continental drift theory talks about distribution of fossils. When identical species of plants and animals were found on land masses, it made Wegener strongly believe that once upon a time there was only a single landmass, and with time it started splitting into different continents. So these were the evidences of Alfred Wegener that made him come up with the continental drift theory. Now coming to the right hand side, that is the post-drift studies. After the World War II, many discoveries were made which added new information. Scientists started arguing the fact that Alfred Wegener only looked at evidences that were collected from the continental areas, which is true. If you look at the left hand side, all these evidences were taken by simply looking at the land masses. So in the post-drift studies, the scientists felt, hey, why don't we do some comprehensive study by mapping the ocean floor? And that led to the convectional current theory, where Arthur Holmes said it is because of the magma present in the mantle which is causing the ocean floor to expand. Since the oceanic crust is thinner than the continental crust, therefore it is easy for the magma to come out from the ocean bed, and that's why the mid-oceanic ridges give a solid proof about this theory. And the second point in post-drift theory is the mapping of ocean floor. When the ocean floor was being mapped, scientists saw that ocean bed is not a flat piece of land. It has similar terrain, uneven surface, just like we have on land. This was an astonishing finding. And then they also went on to find mid-oceanic ridges on the ocean bed, which are these long range of mountains that were formed due to the rocks that came out of the mantle in the form of magma. And when scientists took samples of rock from the mid-oceanic ridges as well as from the continental side, they found that the rocks from the mid-oceanic ridge were comparatively younger in age. Hence, they concluded as we move away from the mid-oceanic ridges, the age of the rocks increases. So this was the post-drift studies, which totally focused on the concept of seafloor spreading. That is, the ocean floor gets pushed to the opposite side due to volcanic eruptions at the crest, and making the seafloor spread and it was presented by Harry Hess in 1961. Whereas the continental drift theory by Alfred Wegener focused on the argument that all the continents were once upon a time a single continental mass named Pangaea, and then this single continental mass began to split into smaller ones, and that's how the world looks today. So if you see two totally different theories proposed by two different people. Hold on, we are not done yet. Now we have a third concept, which brings us to the topic plate tectonics. Now this is the third concept that tries to answer the questions related to distribution of oceans and continents. If you see, this entire chapter so far has been trying to answer the questions related to distribution of ocean and continents. I mean, that's what the title says, and we have so far seen two theories. The concept of plate tectonics was presented by Mackenzie, Parker, and Morgan, three people in 1967, just after 6 years of Hess's sea floor spreading theory. So what the plate tectonic concepts say is the lithosphere, which is also the combination of crust and upper mantle, it is in the form of irregular slab of solid rock. So think of the lithosphere as a large plate, and now when a plate breaks, this is exactly what it looks like. When we say irregular slab of solid rock, this is what the plate tectonics concept is suggesting. So we know that lithosphere consists of crust and upper mantle, and the crust is both continental as well as oceanic in nature. The oceanic crust is thinner than continental, but in general it is one complete crust. Hence the lithosphere covers both ocean as well as land. And now when we think of a plate, we can easily relate that a plate consists of land as well as ocean. Doesn't matter which of the two occupy a larger portion of the plate. Now let's look at the world map. According to this new concept, which is plate tectonics, our entire Earth's surface is divided into 7 major and some minor plates. And these major plates are: the first one is Antarctica and the surrounding oceanic plate, and the second one is North American with Western Atlantic floor separated from South American plate along the Caribbean Islands plate. The third one is South American with Western Atlantic floor spreaded from the North American plate along the Caribbean Islands plate. And the fourth one is Pacific plate, and the fifth one is India, Australia, New Zealand plate, and the sixth one is Africa with the Eastern Atlantic floor plate. And the seventh one is Eurasia and the adjacent oceanic plate. Now let's look at some minor plates. The first one is Cocos plate, which is between Central America and Pacific plate. Then we have Nazca plate, that is between South America and Pacific plate. And then we have Arabian plate, mostly the Saudi Arabian landmass. Then we have Philippine plate between Asiatic and Pacific plate. And then we have Caroline plate between the Philippine and Indian plate north of New Guinea. And the last one is Fuji plate, that is northeast of Australia. Now the reason this plate tectonic theory is so interesting is because it makes a very important argument that continents do not move. In fact, continents are part of these plates, and it is the plates that has been moving throughout the history of Earth. And it will continue to do so in the future as well. I hope you're getting what I'm trying to say. So if you remember, Alfred Wegener said that initially everything was one single landmass named as Pangaea, but according to new discoveries, it is now believed that Pangaea existed due to the convergent mechanism of plates on which continents reside. Convergent means coming closer. Now we're going to read about 3 types of plate boundaries. The first one is divergent boundaries. The meaning of the word divergent is pulling away. So plates that moves apart from each other is due to divergent mechanism, and it creates a fault or depression which is known as divergent boundaries. Places where plates move away is also known as spreading sites. One such example is the Mid-Atlantic Ridge. Here the American plate is separated from Eurasian and African plates. The second one is convergent boundaries. Now convergent is opposite of divergent, meaning coming closer. So what happens when two plates come towards each other? One plate dives under another, and it is usually the smaller plate that converges under the bigger plate, leaving that land area a little uplifted. So this mechanism happens between an oceanic and continental plate, then between two oceanic plates, and then finally between two continental plates. The third one is transform boundaries. In this mechanism, what happens is the motion of the plate is horizontal. Or in other words, here the two plates slide past one another. I mean, the best way to imagine is look at this picture and see how the plates are moving past one another. Now that we have read about different plate movements, it's time to understand what is the rate at which these plates move. I don't know whether you've seen this program that used to come on Discovery called Strip the City. In that, they discussed in one of the episodes how geologists find the rate at which the plates are moving. It is very fascinating to see. What they do is they place sensors all over the regions to record movements of a plate. They use an instrument called creep meter. It monitors the slow surface displacement of an active geologic fault in the earth. Its objective is to record the tension that's building up in the faults. They put two rods attached with steel wire, so when the surface starts moving, it pulls the wire, and the geologists measure that expanding gap. It's usually measured in millimeters, and roughly a fault moves around 5 to 10 millimeter a year. I recommend you watch that video in your free time. It's really fascinating. We now come to another important topic. What is it that is making these plates move? I mean, what is that force? So when we see Earth, we see this round solid body floating in space, right? But I want you to know this solid body is not motionless. If you have seen my video on different layers of Earth, in that I have explained the mantle consists of molten rock and how this magma moves in a circular manner, making the upper mantle a weak layer. And from this weak layer, often heated material rises to the surface, spreads and then sinks back again. This cycle keeps repeating over and over to generate what scientists call a convection cell or convective flow. Again, you can go back and look at the convectional current theory that we discussed under post-drift studies. So to answer the question, what is the force that is moving these plates? The answer is, it is the soft mantle and the circular flow of heated material inside the earth, which is the driving force behind the plate movement. Coming to the last topic of this chapter, movement of the Indian plate. Okay, let me just quickly wrap up this topic in the most shortest and simplest form. Look at this picture. It's the movement of Indian plate. So initially India was part of this huge Australian plate. It was like India was a large island situated off the Australian coast. And this Australian plate was part of the Gondwana land. We are talking about 200 million years ago. Then India broke from the Australian plate and started moving upwards towards the Eurasian plate. About 40 to 50 million years ago, Himalaya started forming. And it is due to convergent mechanism. We have read about this when two plates come closer, a rapid uplift of land surface takes place. That's how Himalaya came up. Before all of this, in between India and Eurasian plate, there was the Tethys Sea and the Tibetan block. While moving upward, roughly around 60 million years ago, the Indian plate faced some events like outpouring of lava, and that's how the Deccan Trap were formed. And you'll find all igneous rock there. So igneous rock is formed from solidified lava. That's how we are sure of the volcanic eruption that happened on the Indian subcontinent. The Indian plate includes Peninsular India and the Australian continental portions. And then if you see the Indian plate, the northeastern side, it extends through Rakinyomo Mountains of Myanmar towards the island arc along the Java Trench. So if you see, the northeastern side is going inside of the Eurasian plate a little bit. And on the western side, we have the Arabian plate, which extends up to the Red Sea. And then if you go to the southern part, the Antarctica plate. So you can see the oceanic ridge, which is a divergent boundary. It is connected to the Indian plate. So it's kind of a nice mapping system when you look at these plates, how they are well connected with each other. So anyways, that was all about the movement of the Indian plate. So basically in this chapter we discussed about three important theories that shape the reason behind the distribution of oceans and continents. They are continental drift theory by Alfred Wegener, then the concept of sea flow spreading, which is referred to as post-drift theory proposed by Harry Hess, and then finally the concept of plate tectonics presented by Mackenzie, Parker and Morgan, which is now well accepted theory when it comes to the reason behind the distribution of oceans and continents. With this we have come to an end of this chapter. Question answer can be found on the website. Link is there in the description. Thanks for watching and I'll see you in the next one.